Hello and welcome to my final Haskell stream of 2024. I'm going to do another admin of code today. Hopefully I'll go better than last week, which is not the best. But I've had a quick look at today's puzzle. It seems more straightforward. So hopefully I'll make more progress on that. And also hopefully the sound will keep working throughout and the setup in general will be better than last time. We shall see how it goes. Okay. But diving into the problem, a lot of text around this, but essentially this is a parser problem. But these represent towels, apparently. And towels consist of stripes of color, and towels are not reversible for reasons. I'll do it again. So here we have a towel which is a red towel, and then this is just a solid block of red, and this is a towel that's got a white stripe and a red stripe, and that's a B stripe, blue, I guess, green and blue and white and U, whatever color U is. So these are the available towels, and using these, we want to be able to create these patterns. So this pattern would be a BR towel, followed by a WR towel, followed by an R towel. So blue and red, maybe followed by white and red, followed by red only. This one is there's a couple of ways you could do this. No, there's not. So it'd be a blue towel followed by two green towels followed by a red towel, something like that. They're not all doable. So some of them are impossible. So this one apparently is impossible. You cannot start with a U. The BWU is fine, but the U is not okay. Okay, and then the aim of this part one is to work out how many of these inputs are solvable using these towels. So I think this is a parsing problem, because I think basically this is a list of input strings. You take your, or these are a bunch of parsers actually. The things you're able to match. Then you take your input string and you say, do any of these match the input string? And if they do, for this example, we can chuck away the bit that matched and we just get left with the remaining string. And then we repeat the process and we keep going until we end up with an empty input. And if at any point we cannot match, then we return an error. And then we'll chuck away the ones that error. Or I guess in this case, we don't need an error, we can return a bool. Or a maybe, actually, we don't need the error itself. We just need to know whether or not it matches. Then we should be left with a list of things you can build, and then we just count them up. So that's the plan. Okay, so I grabbed a test input here. I deleted all the code from last week, but I got a test input ready to go. I might make that a bit bigger, actually, because I normally have it a lot bigger for the streaming. No, one down from there. I think. Maybe not. One down. No, I can't zoom out. Okay, that size is going to be perfect for tonight for reasons. So this is a test input. So I guess the first thing to do is to take the first line, because that's going to be the test input. Not the test input, it's the list of available towels. Then we're going to chuck away new line. Then we're going to take each of these as being a list of patterns that we're trying to match. Okay, so I guess the first thing is that given some input, like some total input, or maybe I'll start from the where to begin. Let's start with towels. So given some string, which is the first line here, I want to return a list of strings. That's what we're going to do. So towels is equal to S is equal to split, which I don't think we have access to. I end up writing this every year. We want to split S on that character. No, on this substring. something like that. So what we're actually writing is split. So split now has got the pattern that we're splitting on and the input string, and then it's going to return a list of results. Okay, so let's do some cases. So split, we don't care what it is, but it was the empty string. It's just an empty list. And then if you have split, we have some prefix of s, where s it's not right. Oh, that's really annoying actually, because I want to go character by character. Let's do it with a character instead. Okay. So if we say we now have s and some remaining, call it rest. If s is equal to the prefix, God, I've forgotten to split a string. This is really annoying. If it's equal to the prefix, then we do want to split at that point, so we need to carry this thing forward. Oh, this is annoying. Let me just go and where can I get split from? Okay, I think the thing I want to use is break. So break, if I remember correctly, I don't know if I remember correctly. I'm going to go look it up. Google. So, I'm just going to copy someone's implementation of split. I want to go from a character and a string to a list of string. Someone will have done this in extra or something. There we go. I'm just going to copy it. Yeah, use break and equals C. Okay. No. Yes. Okay, so we're going to split S. We're going to split the input on comma, and then we want to get rid of the spaces in between. If we get rid of spaces in between, we could have used words. So words will give me R comma, WR comma, whatever comma. So then we can just say like strip comma from words. And strip comma, given some string, we return a string, and then strip comma. What you really want is the last thing in the string. So given some input s, we're going to say case reverse s of, and then if it is a comma at the end of the word, followed by some other stuff, then it's just reverse the rest. Otherwise, it's just reverse. It's just S. Actually, don't reverse again. Let me just call this, we got a name clash going on. Okay, so I don't need to split. Strip comma, I actually want to map over that. Okay, so given this first line, we should be able to call towels, and then it should give us back. Yeah, let me just copy that. Can I copy this? No, not like that. It should give us back a list of the individual strings for the towels. That's a very awkward way of doing it. Copy that. Okay, right. Already in the next shell, that's quite good. So I should be able to say cabal REPL, and then I should be able to load up main.hs, and then I should be able to say towels of that string. Yeah, okay, took me a little while, but there we have a list of towels. Right, so the next thing is, given that list of towels, can we match it against the input? I'm going to say match, and this is going to take a list of towels, or a list of strings in this case. It's going to take some input string, and it's going to give us back maybe the rest of the string. Yeah, okay. I'm hesitating here because I'm thinking about what I want to get out of this. So if we don't manage to match something, I want to return nothing. So you can say that this is not matched. But success will look like just and then the empty string. So it doesn't feel like this type is correct. But I don't want to do bool because I want to be able to call this recursively. So I want to get the remaining string out and call it again. So I guess this is like match as much as you can. So easy case for this, right? We don't care what the input is. Oops. If we are given an empty string, it's just the empty string. Okay, and then given a list of towels and some pattern, what we want to say is if we can match any of the towels in the pattern, then we want to we kind of want to strip the prefix. Is that a thing? Strip prefix of the matching towel. Or this is awkward. Okay, so case match any towels from pattern of, let's say, let me just go to that window 1 second. Match towels and pattern of, okay, so this should give us back just the rest, and that's going to be just the rest. No, it's not going to be just the rest, it's going to be recursive. So if we manage to match something, one of the towels in the pattern, so we've successfully matched it and we're given a result back, which is the remaining part, then we're going to recursively say, okay, match towels in the rest. Whereas if you get nothing back, we're going to give back nothing. We won't recurse in that case. It does shadow that, so I can call this something like get towels. Okay, so now we need to write match any. And this is where we're going to use laziness to our advantage, I think. Maybe. Okay, so this is where I think I should have written the proper parser. So match any, given a list of string, I think this is a really bad way, given a list of string and some test string, is going to give back maybe a string, the remaining part. So we can say match any. If we don't have anything left to check, then it's going to be nothing. Oops. And then we say match any some x and x's, or maybe towel and towels, in some input where we can say t is prefix of input, then that's going to be just strip prefix t from input. This is not a case statement, this is a function with a guard. Otherwise, if it's not a prefix, we're going to say match any of the resulting t's in the input. Okay, and these are from data list or something. And strip prefix should also hopefully be in data list. Yes, but I've done it wrong around, maybe. No. Okay, strip prefix might not be what I want. It gives you back a maybe a. Oh, this might be even better than I thought. Just look up what this does. So strip prefix. Drops a prefix from the list, returns nothing if it didn't start with it, or just the list after prefix if it does. Well, that's the definition I'm looking for here. This could just be strip prefix, which one is it? Drops a given prefix from the list. So I think this is right. So it's t or input, right? But if it didn't start with that, so if we get a nothing back from strip prefix, if we got a just back, we'll return it. If we get a nothing back, then we'll try the other options. Okay, let me pull it in from applicative. Okay, so in theory, I have my list of towels, BRWRR. Can I reload? It's redundant. I don't really care. So towels is get towels. That's still my cup buffer. Yes, it is. Okay, so list of towels, and then we can say match towels against BRWR. That's just nothing, which is a successful match. But if I say U, that should be nothing. Okay, and let's do another one. So like RB BWU should match. It does not. Okay, that's interesting. Oh, it doesn't backtrack. Okay, this is not proper implementation alternative. Okay, so the problem is we can match. It matches an R and it matches a B, then it matches a B, and then it tries to match a WU and it can't. So actually at this point we want to backtrack and say try something else, try BWU. Which is something that a proper implementation of a parser and alternative would give us, but I'm trying to resist the urge to just use make a parsec and do it for me. Okay, so in our parser case, what's going to happen here? So we run parser, and that takes a string to either, in this case, we're going to take to maybe a string. I think that's right. Deriving stock functor. No. Oh, it'll be parser of A. Okay. There's nothing really to do with. The way it's normally implemented is you'd say some input type, and then, well, the way it's normally done is some input type, some error type, and some result. And then this is going to be either some error of IE or A. I need to find what all these errors are. The input type for us is always going to be string. The output type is always going to be string as well, but maybe I could just write an alternative for towels, but it's not, I don't want an alternative for towels, I want an alternative for towel matching. So now can I derive functor? Yes, I can. Okay, so now what? So that's giving me a parser, and then I can define a applicative on that. No, yes, I can find a applicative. Instance applicative of parser, and a couple of things. So pure is parser of the type of parser. It takes a string, returns it turns a maybe A. So we're going to take some input and we are going to return just our input. So we could reduce that. Can I reduce it? I think it's applied too many arguments. The other thing we need is parser f and parser g. I'll come to that in a second. Couldn't match type A to parser. Oh, maybe it's pure input here. So pure is going to say whatever you give me. If I say pure some string, it'll be just that string in the context of a parser. Okay. Right, F and G. What do we want to do here? So we're going to get, we want to run what's going to happen here? We're going to have some input and we want to run F on the input. And that's going to give us back something. What does this give us back? It doesn't work. Let's go pure nothing for a second. So couldn't match expect type parser B with actual type string to maybe B0 lambda blah blah blah. There's one value argument, but its type parser B has none. How do you write? How do you write a parser? So there. Okay. So the type of this thing is now an A to a B. And then Y can be G of the result of that input, but that doesn't make sense because you can't run G on a function, can you? No, I'm getting tripped up. Can I apply X to result of G? Now, what's the type of G? G is something that goes string to maybe A. This is A to B. That doesn't feel right to me. Didn't much expect to type string to maybe A with actual type maybe B. I'm sure you get an input here and you apply it, but this now confuses me because the type of input is a string, so you can apply some parser to the string, so it's like calling run parser, I think. But I thought that would give me back a maybe a string. Doesn't though, it gives you back a maybe A, doesn't it? Oh, I've got myself in a mess trying to remember how to write a parser from memory. Mm, there's an article. This is Haskell parser combinator. This looks like a thing. What have we got on here? Yeah, there's their implementation parser. This is some parsing that I have. Functor instance. I derived it correctly. Applicative, they've got input. Oh, and then they check f input, and if it's left, okay, can I do that? So can I say case f input of, and then here can I say if it's just x, then we want to look at the g of x. If it's nothing, we want to return nothing. Is that right? And then is it just telling me how to make it simpler, or is it wrong? Wow. And now it doesn't work. Finally, at the very end, it tells me that it doesn't actually work. If I get rid of this, and I can't derive funct from it, and I can't define an applicative instance on it either. And if we make these both A's, does that help? It doesn't help, I don't think. It's the same error. Maybe I should do it the way the article does it. So their parser is given some list of i's. I don't really care about that. I'm going to just say given some string, it's either an error or the thing we're looking for and the remaining stuff. The remaining stuff. So we can do that. So it's either nothing, it didn't match, or it's whatever you asked it for and the remaining string. And here, does this work? Can you say just, we don't need to bracket it. If it's just x, then we want to look at, but it won't be just x anymore, right? Because now it's going to return this thing. So what is that? We've got either a list of errors, we can just do a single error, or I'm hoping we can just do a maybe instead of this. And some a, which is what this is parameterized over, and the remaining input. So given some input, this is basically a character in a string. So given some string, they return whatever you're asking it for, and the remaining input stream, like the string in this case. And then hang on a second. Why does that not work? Why does that need to be an A? Because in their example for fmap, the result is a parser of given some input, if running the parser on the input returns nothing in our case. So we say instance functor of some parser, but I can't do this. It needs to be a parser of some type, but I don't care about the type. Okay. All of this is because I really want to implement alternative on the parser, but I don't want to return anything. I just want it to either match or not match. I was really hoping this would backtrack properly for me. Do I just pull in megaparsec at this point? Do I write a proper parser? So run parser has got string to either some error or A with the remaining string, and then error is going to be something like end of input or unexpected. And some character it didn't expect. Deriving stock show and equal. Okay, and then here I should be able to derive functor. And then I want instance applicative over parser. Then pure of some input is equal to parser of anything will give me back right of input. No. No, that's underlined now. That's gone wrong. Oh, hang on. Input and nothing, or what? Where's the implementation of applicative? Ah, no, I've got it wrong. Okay. So this is pure A will return a function given some input, will return that input and the remaining thing. Okay, so what's going on there? Pure A is parser input to write A input. And I've got pure A is parser of input to write A input. Okay. And then the other thing I want is parser F and then parser G. Now this is the thing I'm going to need to copy. What did they say? So, given some input, we'll say case f of input of, and then if you get some error, so some left error, that's just going to be left error, not anything else. But if we get right of something else, so I think they called it input prime and rest, and then this is going to be, what do they do with that? Then they call the next parser. So case G on the rest, they call this f prime of, okay, now we get a left error. That's just going to be left error, and otherwise, what are we going to get? We get right of output and rest prime. And that's going to be something like right of, and then it's, is it f prime of output and then rest prime? I'm going to check that. It's right of f prime of output and rest prime. So this thing applied to whatever comes back from calling the next thing in the chain. Right. And then we can have something like match. I've defined this above, but let's go up. So match is not going to be these things. Get rid of these for a second. So match, given some string and some parser, and then we want to say, how did their things work? So over is this right? So if our input is empty, it's going to get annoyed with me like this, but case input of, if it's empty, then is it pure of, no, it's left. Okay, left of end of input. So we're expecting to match something, but we run out of input. That's an error. Whereas given something where the head of the thing is equal to not quite, because we're not dealing with a single character. So now we want to say, given some s, where s is prefix of let's call this as prime. So s, the thing we're looking for, is a prefix of the thing that we've got. All right, then they return right, the thing we're looking for, and the remaining stuff. Okay, and this is where we could use strip prefix. But we're no longer in a maybe type, so we can't use strip prefix. Okay. So given some s prime, we can say case strip prefix s from s prime. If that is just the remaining stuff, then we can say right of s and rest. And if we get nothing back, then we say left of unexpected input, whatever my error was, I just call it unexpected. And the thing that was unexpected was s prime. Okay, like I said, it's going to get annoyed with me, so what it really wants me to write is that, and now it would be annoyed because that needs a language extension. Okay, now s prime, yes, my error is wrong. It's not an unexpected character, it's an unexpected string. Okay, so what am I doing here? So they have got input, which is a string, and they return the head of that, which is going to be a character. And I'm returning something which is a string. What I've said here, okay. Not make that, I just made that explicitly a string. Okay, so in theory, I should be able to call match, I should have called run parser match the thing I'm looking for, and then some input string. So I can say something like run parser match foo in foo bar, gives me back right of foo that's matched and then bar. Whereas if I say looking for bar and foo bar, it doesn't find it. And then can I say match bar or foo. No, because I haven't implemented an alternative yet. That's where I was getting up to. Alternative of parser I need to include this. Okay, and their definition of alternative should just be try and match left. If it doesn't work, try and match right. So we need to define empty, which is a funny case, but then we need to do try left or right. Then if left works, we return it. Otherwise, we try right. And if that works, we return it. Otherwise, return. I'm just going to return first error I find. I don't need to join them all together. So empty is a parser which takes something, doesn't care what it is, and it returns left of, I think they've created a special error type for that. Alternative. Okay, that's empty, and then you can say, so parser left or parser right. So we say case. It's going to take input, it always takes input. L input of, is that right so far? I'm going to write the whole lot in a parser as well. So I could say pure at this point. So given some input, case input of, and then if it's left error, we just want to return that error. And if it's right, no, we don't want to return the error, sorry. We want to run case right input of, and then we can say, if this is left error, then we give up. But if it's right and it's returned some stuff and the rest, so some X and the rest, that's going to be right of X and the rest. And this is going to be the same thing, I think. So right put rest, right put rest, right put rest, right put rest. Get an error, try again. They've got a list of errors and they're just deduping it. But I don't care. This should be error prime because we've got a name clash there. That fixes that. Couldn't match type A with actual input type string of that. Okay, I've done something wrong here. So parser left or parser right is, let me get rid of my pure just in case that's the problem. Okay, we're getting closer. If we get an error on the first one, we don't care. We can return any old error. Okay. No, not that. Not that. That. Reload. There we go. Okay, so now we can match left or right again. And we get right of boom bar, and this all runs inside the parser. Now, can we then have a match any, which is all of these things, and then do them one after the other? So we could have that's going to match a single thing. You can say match any, which is given a list of string. Given a list of string and some input string, we want to return parser and anything that's left. So match any, given some towels and some S. Right, I'm going to have a quick look at the implementation of alternative, because I'm hoping there's some kind of any inside there. One or more, 0 or more. So sum is that what I want? No, I don't think it is what I want. Where am I now? This is in applicative. Okay. So some parser will attempt to parse one or more times until it fails. It's not quite what I want. But it will be in a minute. What I really want is given some input list to turn it into this kind of thing. So I want to go from a list of strings to a parser. And I believe there's a thing called any, but I don't know where it is. I don't think that, no, maybe not. So any towel given a list of towels is going to return a parser of those things joined together. So any towel of an empty input is going to be pure empty input. any towel of a towel followed by more towels is going to be match T or any towel T's. Okay. So then if I grab this string again, and then can I say reload, and then do we have any towel? Oh, hang on. Sorry, we can say towels is equal to get towels. That. Okay, and then what did I want to say? I wanted to say any towel of towels. That should give me back some kind of parser. I can't show the parser, but I have the parser. And then we can say run parser, and the parser here is any towel. Maybe we should just call it any of. And then my input string could be something like BWURB. Okay, and that works because we get this first thing. I feel like I've just gone a very long-winded route to get into the same place again. I'm going to call this any of. Okay. Then I was going to say many. So I can say match pattern. Given some towels, it's going to return parser string. Towels is a list of strings here. Match pattern. Oh, it needs to take a list of things we're matching, then the input, like that. So we can say towels and S. I'm going to say many, any of towels in S, but this is really run parser. No, hang on. We just need that, and we don't need that, and we don't need that. So any of it takes a list of things and it gives me back what's many. This is many. Where did I find many? Some. So some will give me back this. What was I run it? match pattern. Oh, else is that, and it runs forever. Okay, that was not correct. So I've just made this worse basically by re-implementing a parser. Oh, I thought this was going to go better and it really hasn't. I should have just grabbed like a parsec and done it like that. It'll take a while to install. It didn't take a while to install. Good. Must have installed it already for something. So if I go back to main, all this shit, use someone else's parser. So can we get rid of that as well? Can I say import text dot megaparsers dot megaparsec? Restart LSP. Language server failed. Good. Not good, obviously. Compile build. Why did it fail? Text megaparsec. Okay, it's finally there. As P, and then I can say type parser equals P dot parsec. We're going to go text. No, we're going to go character and void. Okay. No, I can't remember how to use megaparsec even. So what I want to do is megaparsec. Yeah, give me an example. So, oh, I've got it right. It's void and text. And I can drop this off because it will reduce text. I want text, I want string because we're not dealing with text. Give me some idea of the primitives. Do we have a string? No, is that actually in megaparsec.char? Looks a bit better, maybe. Single character string. This could give me string. Okay. A synonym for chunk. This is complicated. Chunk. Okay, so, and where's that in? That's in just in megaparsec. So you should say something like parse towels. And that's going to say, given a list of strings, these are the things we're going to match. And it's going to return a parser. So parse towels, given an empty list is just that. Can't do parser, it needs to be parser A. And to return an A, oh, for goodness sake. It's got monoid, so can I do empty? And then parse towels of some T and some T's is chunk T or parse towels T's. No, because chunk isn't happy. Okay, this is getting me back to where I was before. So can I say val REPL, and then what have we got? Parse towels. So we can say towels is equal to a list containing R or B or RB. Let's make it something RW. And then can you say run parser? Import text dot megaparsec run parser. Can I load app main? Why is it not? Why is it not available? Common shared. Oh, because I put it in just for the executable. I put it in there, it should be available to the REPL as well. What's it going to? I'm going to load up main JS. What am I doing? Okay, and then can I import text.megaparsec? Not like that. Text. There we go. Okay, and then has this got run parser? Yes. Okay, what was my parser called? I've forgotten already. This was called parse towels. I've lost my definition of towels now. A, B, and CA. I'm going to run it over. I think contains A's. Oh, hang on. What arguments does run parser take? I just wanted to call parse, not run parser. Nope. Was parser given something with the name of the source file, which comes before the input. Okay. Okay. And what I want to then have is something like parse pattern, which given some towels and some pattern, no, it's not given a pattern yet. So this is going to be equal to, give me some towels. It's going to be many parse towels of TS, like so. This isn't really helping. Followed by an EOF. Have I got p.many? Yeah, but it's the same thing. And maybe a p.eof. Okay, and then parse pattern. That works. But if I put a U in the middle of that, it doesn't work. What does parse test give me? Parse maybe is maybe what I want. So can I say parse maybe? And then I get rid of this. Nothing. Okay. And then that. Right. But does it actually work? So I get my list of towels back. Oh, I've lost get towels. Do you know what? I don't care. It's getting to the point now where I just want it. I just want something to work. And then we say parse pattern towels And then the input string that worked according to the puzzle example is BRWRR, and that works. And then BGGR works, apparently. And GBBR and RRBG, RBGBR, that works. UBWU should fail. Okay, BW. The next one should work. And that's the one that failed before, and it failed again. So there's a thing you can do for megaparsec to tell it to backtrack, and I can't remember what it is. Megaparsec backtrack. Backtracking. It was on. Try. What's the source of try? It doesn't say here. So let's try this or the next pattern. I really wish I hadn't rewritten this as folder. Okay, so given some towels. What I might say is if we don't have any towels, we expect, if we run out of towels, we should also run out of, no, that's not right at all. Let me just do p empty. So parse towels is getting really late. Given some t and some t's, it's going to be try chunk t or parse towels with the remaining t's. Okay, just want to try in the middle of that. Oh, where's my line for towels? Nothing, it still does not work. BWU-RRG, 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 it should work. So I don't know why that try didn't fix it. Okay, I'm going to stop, it's getting late. Once again, I failed to solve anything at all in Advent of Code. I half wrote a parser, and then I pulled in megaparsec and it still didn't work. In theory, this should be quite straightforward to do, but I just don't know how to do it. But writing a backtracking parser in Haskell should not be a difficult job. But it defeated me anyway. So cool. Sorry I didn't get any further today. Such is life. this is the last stream of this year. I'm going to be back on the 10th of January, I think, something like that. So yeah, hope you have a good break. And I will see you next year for some more Haskell fun. Hopefully more completing puzzles or writing some proper code that works. But yeah, thanks very much. And see you next time. Goodbye.